Hi everyone, this is Al Gaeta in Lexington, Kentucky. This section of my video I describe how I created the parts that are used to mount the bell housing and the flywheel to the motor. And then also how I made the parts for the front motor mount. And here we start with the two pieces of iron that are going to be used to make the adapter. And after some machining and fooling around, I've got these two pieces here. Now the round piece fits exactly into the recess in the square piece, and it's held there with the 4 bolts. Another thing you have to do is you have to make a keyway in the adapter here that matches the keyway in the motor shaft. So how you do that is by using a broach. So what you do is you would just drive this down into the hole, and every little tooth you see there sticks out a little bit further. And so eventually they cut the notch in the round inside of the adapter. Now here I've mounted the little adapter onto the motor shaft. Now this has to be a really good tight fit. So I machined the internal bore on the adapter to almost fit onto the shaft when you do it by hand. It's to the point where you could drive it on with a hammer if you wanted to, but we didn't do that. That's kind of crude. What I did was I heated up that little round adapter to about 140 degrees, and that got just hot enough so that it expanded the inside bore, and the adapter just slipped on the shaft ever so perfectly. I pushed it all the way back to the shoulder that's on the shaft, and then let the whole thing cool off, and use set screws and other stuff to really hold it down tight. Remember this square piece? Well, this piece has got to become round to fit into the flywheel. And here I am machining the corners off of it and getting it perfectly round. And notice on the top edge there seems to be a little recess, a little groove. Well, that has to fit exactly into a matching depression on the flywheel. Now here you can see that I've mounted it to the original adapter that I put on the shaft, and once again you can see that little maybe 1/4 inch of recess around the perimeter. Now that has to fit into the recess you see on the flywheel with the 4 bolt holes inside, and once again I made it a perfect fit. It would not fit by hand, but when I warmed the flywheel up it would fit on just great, and it would cool off, and it was really difficult to get off. The next thing that we did was to dynamically balance the flywheel. Look at the bottom of the picture and you can see the heads of some bolts there. Well, there were some unused holes in the flywheel, so I tapped them out to 1/4-20, and I got some 1/4-20 bolts and screwed them in, and those were my weights. They came in different lengths, so I had a 1/10 of an ounce and a 1/2 an ounce and stuff like that. And so I would spin the flywheel and notice the vibration, and then put a weight on and spin the flywheel and see if it got better or worse. And it just kept doing that carefully and deliberately. And after a couple hours, I had it down to spinning just dead quiet. There was no vibration whatsoever. This is the front view of the flywheel. Notice the numbers on it. Those are what I use to help me do the dynamic balancing. The 4 bolts on the outside of the recess, those are holding the flywheel onto the larger round adapter that I made. And the 4 bolts on the inside are holding the 2 parts of the adapter that I made together. These are all category 8 bolts, which, like I said before, they are tough beyond belief. I put them on with an impact wrench, and you can tighten them down till they ring like a bell, and then you know you got them tight enough. This part is a close-up of the final assembly of the flywheel and my adapter. The smallest diameter thing you can see in there is the one half of my adapter, and the next largest thing is the other half of the adapter, and they are bolted together. Then onto them you bolt the flywheel, and then ultimately the clutch housing, which is in red. Well, okay, everything is assembled, and I'm going to put this thing on, I'm using a battery charger that's pretty substantial here. So here we go. This will bring it up to about 12 or 1300 RPM. Okay, that's pretty much evened off. I'm going to up the charger. This ought to be about 2000 RPM. I'll bet you never thought you could cut through a 2-inch thick aluminum bar with your mighty Craftsman radial arm saw with a regular metal cutoff wheel in it. This is for my adapter plate, and it's 2 inches thick and it's 1 foot across. And I'll show you what it sounds like and what it looks like when I cut it. It looks to me like I'm taking off about a 1/16 of an inch or so on each pass, and the wheel does not seem to be wearing down awful fast. I think this is it. Yep. Yeah, there. Not bad for a wood saw. After cutting it off with my radial arm saw, I went around and machined all 4 sides to get them perfectly smooth and square so I could use them as references as I was doing the rest of the layout. One of the things you had to do was to be sure that where you bolted the motor up to on the adapter plate was in the correct position in relationship to the bell housing and the transmission pilot shaft. And so here I am locating the bell housing on top of the piece of aluminum. And after a lot of machining and fooling around and measurements and remeasurements, this is what my adapter plate ended up looking like. The big hole in the middle of the adapter plate is where the drive shaft or the shaft of the motor is going to poke through. And then you can see there's holes all over the place. One set of holes bolts the motor to the adapter plate, and the other set of holes bolts the bell housing to the other side of the adapter plate. Another thing to be done was to try and lighten up the flywheel. And so this thing weighed 45 or 50 pounds all by itself. So here it is. I've got it up on a rotary table on the milling machine, and I'm using a dial indicator to get it so it's centered and perfectly round on the rotary table. And then I started to just go around and cut a groove down into the cast iron to reduce the diameter. I probably took about 3 or 3.5 inches off the diameter. And a funny thing was, I thought the gear teeth were molded in or cast into the flywheel, but they're not. They were a separate steel ring that had been heat shrunk onto the cast iron flywheel. That was an interesting surprise. Well, success at last. The motor is turning, the clutch is clutching, the transmission is transmissioning, and if you look way to the right, you can see the parking brake drum kind of wobbling around. I put it on crooked so you could see it was actually turning. Well, here we are. After some more fooling around on the test bench, it's time to put the motor back into the vehicle. And this is how I did it. It took a bunch of jiggling and fooling around and stuff, and getting bolt holes to line up on the rear motor mounts. And it was not too bad a process, but it took a little time. And this next picture here is, it's all installed, except that there's no front motor mount. It's being held up by the chain from the engine hoist. Okay, the next task at hand is to make the front motor mount. So what I've done is I went to Granger and I got these nice rubber shock mounts. As you can see, it's threaded on both ends and it's rubber in between. It's got a big metal plate right here. And you can buy these in all shapes and sizes. You can buy them with different weight ratings. It's all over the lot. So if you're looking for shock mounts for your motor, Granger is a good place to get them. Anyway, I got two of these, actually four of them. One goes here, one goes here, and then the cardboard is just a marvelous prototyping tool. Whoop. There we go. And so this goes in and this sits on the rubber shocks that are sitting on the edge of the frame. So here's how it all looks when you get it put together. And there you have it. I'm going to build it out of 3/4 inch aluminum, whatever that good quality aluminum is, 60/20 or whatever it is. And it's going to be 3/4 of an inch thick. It's going to sit directly over the hole, so the notches in the aluminum are going to be screwed into the shock absorber. And then you might ask, what is this for? And it's going to form a shelf. This and this are parallel, and I'm going to put a shelf in here, and the shelf is going to be where all the high power electronics is, including the controller and the contactors and all of that stuff. So hope to make it quite compact. Next thing I did was transfer the pattern from the cardboard onto the aluminum plate that I got, and then took it over to my metal cutting wood saw and hacked off all the pieces and stuff. I did some machining to round up the corners nice, and this is the finished product. You can see the circle of bolts that are going into the motor, and you may notice on the left hand side there appears to be a patch, and well, I was hoping I could get that in place without cutting it, but I just could not get the aluminum front motor mount maneuvered into position. The frame and everything else was in the way, so I finally just cut it and made that patch. It's not too pretty, but it will certainly do the job. Yeah, this is like telescopes have first light. We in the EV community have first revolution under power. On the left-hand side, you can catch the universal joint and the emergency brake drum going around. It's a pretty big milestone. I just thought I'd give you a videotape of the drivetrain actually working and turning the back tires. Well, there's no tires there yet, but you'll see. Yeah, that's third gear, I'm pretty sure. We'll go for a shift here and see what happens. No, that was second gear. This is third. And there we have reverse. And of course, neutral. And that, of course, is one of the back tires going around and around and around. I know most normal people never thought of this, but have you ever wondered what it looks like inside the transmission with the gears spinning around in the heavy oil? This is 90, was it 70, 90 weight or 80, 90 weight gear oil. And the gear on the left-hand side looks very well lubricated, and the others aren't doing too bad. On the right-hand side, you can see it just starting to sling the oil off of the gear. And so if I went any faster, I'd get oil all over the place. Anyway, that's it for the mechanical part. The next step here is to put the body back on and then do a bunch of electrical work. And here at the end of the day is another wonderful Kentucky sunset.